modern data platforms. I'm surprised that people are here. It's nowadays all about services. Yeah, and services, you put them in Docker containers and you're just sending them around and everything works. But there's still data. So, who am I? Dominik Wagenknecht, out of the Accenture office in Vienna, Austria. Senior technology architect, and like many people that are talking in this particular track from emerging technology. I'm from Austria. This is the place where the Accenture office in Vienna is located. It's the old Börsegebäude. It's a very traditional location. It was built in 1874 to 1877 by Theophil von Hansen in the style of Renaissance revival. So it's not actually that old, yeah, because it's 1800 something, which is pretty new in Austria. The house I live in is from 1890. That's pretty normal. The strange thing also is, this is a little bit of a corollary. In all our new cool systems, we have now adopted DevOps, and we have microservices, and we have all that stuff. But the database below it is often still old. And, well, that's like it is. So, you adopted microservices, or at least now the entire morning, and then with Amazon Web Services, and with Docker. You drank the Kool-Aid. You believe in it. It's cool. So, your CI/CD pipeline is pure magic. You're doing 60 deploys per day, at least. Your team is super motivated and happy. If not yet, then Ilka will show you in the next round how to do it. Your feedback cycle is super short. Business feels the progress. Every day they click in it and they're just wow. And are thinking what to put into your backlog because you're overachieving. And you have great monitoring. You did all that stuff. Yeah, so you have the microservice, of course, that added a lot of complexity. You're monitoring everything. You're seeing everything. Everything is cool. And then you're looking at Martin Fowler again, and you see, ooh, criteria of microservices. Shit, I need decentralized data management. What does that even mean? And then you start trying it out, and it turns out this is really painful in Docker. It's really freakingly easy to send a Spring Boot application or a PHP application or your Ruby on Rails stuff from your CD chain somewhere into your cloud, Docker-based deployment, whatever. Super easy. There's a registry, you have one command, you start it downloads the 240 MB. No, you did everything right, so you took a slim Docker image, it downloads 50 megabytes and starts it. But there's data. And data is typically hundreds of gigabytes, terabytes, and doesn't start within seconds because you have to move that stuff somehow, or ideally you don't move it. So, you took that serious. CI/CD pipeline still rocks. You have your API gateway in front. Reading from the back, you obviously have APG. Then you have all your services in place, which are continuously replaceable. And then you have a database, and your database guys or your developers are now like super happy because now you can do different database models. Yeah. So you have, thankfully, sensible architects saying that, well, your master data in here really has transactions, so maybe we should go old school. Yeah. But there is this much more flexible stuff where users can enter their stuff, where they can do like, I don't know, blog posts or something that is extensible, where you need the flexibility of JSON, and there you go for something like MongoDB or, of course, Couchbase. If I had known that earlier, I had put the Couchbase logo in there. Awesome way to attach it. And then you have this complex customer relationships, and I can only recommend you that. So if you're in banking or insurance and something, and it turns out that you have like 10 core systems, and it's like really, really tough to have one view on the customer, yeah, because you could have him like with 5 different customer numbers. And it's actually a complex thing because you want to have the relationship. Private banking is always a fun thing in that regard because you have the rich guy, yeah, which is in private banking, but then this guy has a cousin who actually doesn't know how to deal with money, but still he should get better treatment at the bank because he's related. Yeah, I mean, that's not a joke. That's business requirements. By the way, using a graph for that is really good. But now you have that. And you're synchronous. Now, a lot of vendors will tell you that it's bad. We're asynchronous nowadays. But that's not the truth. That's a good thing. Yeah, 90% of the standard requirements that you have, and I'm going to come to the other part later, is synchronous. If you click on a website and you want to see your transactions, or you want to see your energy bill, then that's a freaking synchronous call because you want an answer now. So you're doing the right thing, don't worry, yeah? And of course you employ a circuit breaker and all the goodness because on your website you have a lot of information, but just because one service fails, that does not mean you can't produce a meaningful answer. Maybe you have a little bit less data on the website, but you can still produce a meaningful answer, and by using the circuit breaker, get better 99.9% latencies and stuff like so. The fun thing is, we have now all the new models in the database, but we're still using them in the same way. It's essentially CRUD. All three databases here are essentially CRUD, and Couchbases as well. You can create, you can read, you can update, you can delete. And of course, depending on the model, you can do a little bit more fancy stuff, like in Neo4j, you can do a graph traversal. In the others, you can do views and stuff like so, but it's really create, read, update, delete. So life is good. And I have a few tips on the end how to deal with that in Docker and still be nice. But there's the bad guys. Business wants more, way more. And I'm seeing that, we are seeing that as a company all the time. And the solutions we had, or we are employing up until now, a little bit half-hearted, so to say. Business wants more interaction. If you have a smart home system collecting your energy data or showing you the temperature in your living room or something, and you have an app or a website that gives you the possibility to interact with it, do you really want to hit the reload button to find out that the temperature changed? I mean, it should change automatically, yeah? Or if you have a home sound system like Sonos, which is cool, then naturally you would like the website or the control surface to update itself and tell you which song is playing right now, and not you hitting refresh, doing a synchronous call and then going back. And business in some way wants exactly that kind of interaction. So they want to have mobile push with content in near real time when something is happening. Yeah, if you draw money from the ATM, in the next second your mobile phone should vibrate, essentially. Or if you're wire transferring things or opening new accounts, or there is some possible incident. Yeah, electricity company realizes, oh, there's a sudden spike in your energy consumption that is totally. What is happening there? Yeah, probably we should give the guy an alarm, and then you can find out, well, your house has just been robbed. You want personalized email and that kind of stuff, and you also want more smartness. So there are asynchronous use cases that take some time, like fancy fraud detection, next best action. So what should I show my customer as, what should I propose him to sell next? Yeah, that take a little bit of time. You need analytical models for it. You need to have a proper fit, and it's not part of your synchronous pipeline. If you put all that into the synchronous interaction, and while you're rendering your transactions in a bank or showing the energy consumption in a utility company or showing the next train connection, while you're doing that, you probably don't want to spend another 200 milliseconds finding out which advertising to show. That doesn't make a lot of sense. So there is this asynchronous thing. And this asynchronous thing is coming closer. And I've seen now recently requirements like, we found out that our customer support can't really help people. Surprisingly. Do you have in your companies public-facing websites with logins for your customers? Yes? Yeah. If I'm your customer and I call customer support, and I say, like, I see this weird thing here on the website. Can the guy go in and see in my session what is going on? Not really. And I'm just saying this stuff is coming. Oh no, this is really weird. So let's go for the example of mobile push. How would you do that old school? Well, we need to decouple. That's pretty clear. We don't want to do the mobile push within the synchronous pipeline with retry or whatever. And it would lead no longer to microservices. It would be then one big thing, because in the same service I have to push and I have to do everything. So we need to put that stuff into a queue. We already learned today from Matt, queues are not cool. I'm arguing in general queues are not that bad, just specific implementations are problematic. So you push it into a queue, and here I'm going real old school. You have a message-driven bean, so welcome Java EE world, listening on the queue, and then it pushes. And that's a good way to implement it, because it's decoupled, it is robust. Yeah, if the push fails, then I can retry. Yeah, you have all those transactional guarantees and so on and so forth, but it is still pretty old school because compatibility and so on is really bad. Because if you read it from the queue, then it's no longer in the queue. So you cannot add additional services on top of it. You cannot run two different versions in parallel and test something out. So especially if you're going for this asynchronous queue-based stuff, you will find out that the microservice approach and this Dockerized way we do nowadays, yeah, you just deploy it out and then you run your calls, it just doesn't work, because you have to flush the queues, you have to put the test data in, you have to do stuff with it. So it's not as nice in that way. So it composes really badly, and it forces people in this testing into this really tedious processes. You have to write your own drivers and so on. Now, how would that look like in a microservice approach? Yeah, we would hook up something. So as you can see, this picture is not getting simpler, but I mean, we're producing more business value, so at least something. In this case, the service, which hangs on Neo4j, so obviously we are sending out a push if you have a new friend or something like that, because it needs to be something graphy. So when something is added through the API, you make a post, you make a put to it. The service not only stores the data in Neo4j, it also puts a message on the queue. There, the trustworthy push mechanism listens and then uses the appropriate protocol to send it out to Google and Apple. The two are wildly incompatible from a protocol view. So now we have decoupled. We have a synchronous part on the left, and we have an asynchronous part on the right. And we have mobile push. Trick question. Could we do the customer support thing that I mentioned earlier with that pattern? So it turns out from the business requirements, and I have not yet found a formal definition of that stuff, but it turns out there's actually two kinds of asynchronous communications. There is one that is kind of out of band. So here we are out of band. This can happen at any time. It is a completely different channel. It is a completely different device. And there is the other stuff, this full interactivity, and I don't really know how to call it, which you typically have with WebSockets. So for example, if my customer, do I have a pointer here? No. If my customer in the browser up there wants to have an interactive chat with my customer service agent and wants to access the same data, then you need an asynchronous backfeed within the same session, so within the same band. It's no longer decoupled. So this is not solved with that way, but it is a stepping stone in that direction. You could have your WebSocket connection up there and so on and so forth. So how do you approach this new world? And I want to essentially show you that in sizes small, medium, and large, plus essentially one dark horse. How could you approach this kind of use case? You then have to play around with whether it works with out of band, in band, I don't know how to call it. So, a little bit of detour first. This is certainly wrong picture, because it doesn't fit on any particular vendor, of how a database works. And this is now independent of whether it is a NoSQL database or a SQL database. This one is obviously a SQL database. But what happens? Whenever you do something on a database, insert, update, commit, whatever, yeah, you're communicating to your database. And interestingly, whereas in the past, the database would go there and just replace your data in line. Yeah, you do an update on a specific road and it would update it in line. This has changed completely since decades, essentially. The current way how you build that, and since ages, and even MongoDB realized that at some point, is you have a commit log. Yeah. So before you store the transaction in the actual data store in place in sorted fashion or however it is optimized, you have it in a commit log, which is a very, very interesting place, because in the commit log you have a sequence of stuff that happens. And this sequence of stuff that happens is essentially the trigger point for the interactions that your business wants. If your business wants a push based on a new transaction, based on a new friend, based on some limit reached, based on whatever, it always triggers down to something like that there is an action, and this action should trigger an asynchronous reaction in some way. So for very forward-looking services and very forward-looking databases, and we will come to that, they build the streaming capabilities on top of their commit log. Couchbase, for example, does that in that fashion. They have this cross-data center replication log, which they should probably rename at some point. They are using it essentially to send all the updates from one cluster to another cluster. That's the base use case with which one they started. But nowadays, you can also push the data to completely different systems. And they do that by hooking up to this part. But more to that pretty soon. So, modern data in small. The idea is pretty simple. Don't do it yourself. Don't invest too much resources. You could just build your little silo of interactivity next to it and use a service like Firebase, which gives you that push. Interestingly, a lot of the services that are built as platforms for mobile services have exactly those capabilities. You can listen to changes and essentially react on them and do pushes and so on top of them. A very interesting player is RethinkDB. RethinkDB has a feature called live query. So you can essentially tell it, well, give me the top 3 scores, or give me my top 5 friends, or give me the highest usage over the last hour. And as long as you have that query open, and you can have that connected to your WebSockets connection, as long as you have the query open, when something changes, your code will automatically be informed about the new state, which is very nice to program against it. And I mean, it's a young database. I'm not sure at which scale you can really do that, but for small, you can certainly do it. A system that does that as well is Meteor. Meteor ideally runs on top of MongoDB. It's a framework where they have very, very smart logic that when you do an insert or an update, they find out that at some other place someone is listening to that data set, and thus they enable the interactivity. Again, from a scaling thing, a little bit complicated. The interesting thing, however, is a lot of that stuff is based on the replication mechanisms. So this has been retrofitted to systems like Cassandra and also HBase by just listening on what changes happen. If there's insert, update, delete, I can figure out whether the select query I'm watching is interested on that. And that's just what, for example, PipelineDB does. So that's like starting for small. If you go bigger, you probably want to do the stuff a little bit more explicit. You want to have more control around it. You no longer want this smart box, this one box or this service that somehow does magic, and you have to buy very expensive people, like when you're optimizing on an Oracle and you have to find someone that understands what the query optimizer does in that specific situation, which is always a weird thing. So here you go a little bit in the direction, let's go for messaging. and let's use something modern where we can have pub/sub methods and so on and so forth. So you could use something like RabbitMQ, or you could go, and this is something we are seeing at many, many clients nowadays, or you can deploy Kafka. However, here is a very, very crucial step. Kafka is a distributed system. You will need a zookeeper cluster to run it. So you're going into dangerous waters from an operational complexity perspective. Because as long as something is only on one single machine, especially also for your development test and integration test environments, you could still Dockerize that and do some snapshotting and so on and so forth. Once you go for fully distributed, it gets complicated. How do you do a snapshot in a distributed system? You then need to do that per technology. And if you look, for example, at Cassandra, it is plain impossible to do a consistent snapshot. You just can't. So here really my argument is keep it simple. Fill the messaging from your application, or maybe there's an easy hook in your database. So if you're using something like Couchbase or similar, you can hook up to this cross-data center replication. And just do the processing within your own code. Just listen to the messages, changes, and all you need is a little bit of leader election, because you have your cluster, yeah? You have all your microservices deployed, but you of course want to make sure that the message is only processed once, so you need some kind of leader election, which you can easily do with console, etcd, zookeeper, which you maybe have already if you have a Dockerized environment, or you can use a library like Atomics in Java, but there's your ways. And this is large. If you're going to do that at large scale, you really are going towards a big data platform. There you really only have two choices. You have either Hadoop, and then typically you have the entire ecosystem with HBase as the operational database, Kafka as your messaging store, and then a wide range of options for your complex event processing, real-time analytics, or however you call it options, like Spark Streaming, Storm, Samza, Flink, and so on. So you have a lot of options there. You really have a lot of options. We are currently seeing most implementations gravitating towards Storm for simple transformational jobs. Like, for example, mobile push done in Storm is super easy. And it scales like nothing. It's really nice. So if you just have code that should operate event per event, go for Storm. Really good. If you're going for sliding windows and you have to do analytics and so on and so forth, you should really head towards Spark Streaming. That is where we currently see that this big data area is going. And if you don't like Hadoop, and Hadoop is a complex setup, then going for Cassandra, and especially the data stacks distribution, is easier to a certain degree. However, then you're on a smaller island. So the Hadoop island is pretty good, pretty big. There's a lot of investment in there. There's a lot of compatibility in there. If you go for Stack Overflow or something, you will find a lot of help. If you're in specific situations within the Cassandra with Spark combination, it gets a little bit thinner, of course. How does that look like then in an extreme way? This is a way we did it for a banking client in Austria. And essentially hooked up to legacy. And that's pretty funny because they have their classic applications. In this case, this is COBOL transactions doing stuff against DB2 and ZOS. And then on DB2 and ZOS, we have a commercial log replicator running. This is the commercial part in it. There are multiple options on the market, like for example, Infosphere CDC from IBM or Oracle Golden Gate. And there are also smaller companies. And once you have it in the log replicator, you can pump it out to Kafka. And this is fun, because suddenly you have outside of the mainframe the entire data flow in Kafka, which is a messaging store, which enables you to hook up to one topic as many consumers as you like. Yeah, so you can have the operational processing that just makes a copy of the data, and you can have some stream processing that does some fraud detection, and you can have some other stream processing where you're just trying something out, and they won't interfere with each other. So this is also a route towards bimodal, multi-speed, however you call it, IT. So you can speed up, because this is pretty non-invasive. You install a tool that listens on the log replicator. Of course, you have to be a little bit careful. You have to look at performance impact and so on and so forth. And you probably need a commercial tool. There's no really good free log replicators that can read the binary logs of DB2, Oracle, or what have you. Fun thing is, some of the more forward-thinking tools already have that feed somehow, so you can hook up to it. Especially for MariaDB and MySQL and so on, there's stuff out there. I think LinkedIn programmed something to do that. Makes sense so far? Good. And here we come to the point of pragmatism. Because when you tell that story, how do you get this new business feature? Then everyone thinks he needs the big solution, we need Hadoop. And then they go for the big thing. But that makes it really, really, really hard, because I'm arguing stay small as long as you can. Yeah, leverage that you're going on microservices, because that means that each individual database is smaller. It is important to understand that physical doesn't mean that physical is not the same as logical. It's absolutely correct to put the data from multiple microservices into the same database instance, as long as you have separated them by whatever means the database provided, be it buckets in MongoDB or namespaces in a relational database or something else. Yeah, you don't need to build up a cluster for each and every microservice. But I would keep it so small that at least in the development environments, you can leverage stuff like XFS with LVM to do snapshotting. Yeah, because you want to rerun your tests in your CI/CD pipeline really quickly. So you want to have some method to, within seconds, bring your database back to the original state, run the test, set back, run the test, set back, run the test. And that works really well as long as this stuff fits on one machine. Or you use BetaFS on Linux, which has very nice snapshotting capabilities, and you can jump back. So that's essentially my point about stay small, be smart about how you work with your moving parts. If you really need it, of course, you can go big, but please think about it. It's not just installing the thing, it's really about running them, it's about having it in your test environments, it's about having snapshots and so on and so forth. For Hadoop, we pretty much know how to do that. There it's snapshotting, everything is there. I'm not so deep in the other technologies to really know it. Funnily, and with that I'm closing, more than in time it seems, there's a dark horse. Who's using an in-memory data grid? Anyone? No? This is fun. So these technologies have been out there quite a while, and a lot of them have been open sourced. Yeah. So for example, Apache Ignite is originally GridGain. Apache Geode is it's still incubating in Apache is Gemfire from Pivotal, and then there's also stuff like Hazelcast. This stuff is not micro, this stuff is not stateless, this is not microservices stateless or anything. It's a cluster of machines sharing their memory and shuffling stuff around. So it's a distributed monolith, so to say. And you always had it in investment banking and stuff like so, where ultra low latency is really important. However, I would make the argument that for a few services, it can totally make sense to apply something like that. Because within an in-memory grid, it's no problem to get all the communication from the different sessions you have open to your clients, redistribute the data, and read from the other side. They have those features like continuous querying and so on and so forth. Yeah, so it's really worth a look. It can be that for a medium-sized thing that no longer fits on one machine, you don't necessarily need Hadoop, but you can really go for an in-memory data grid, in-memory persistence, or however you call it. Just please be careful, because the more logic you throw into it, the more you run into the risk of having a monolith. So hook it up with the outside world. That's really my recommendation here. That's the same also, for example, for actor-driven systems. If you have an actor-driven system, like, for example, Akka or so, it can grow big. It can grow really big. And there is a temptation to do that. And it's okay to run them bigger, but not necessarily too big. Thank you. Any questions?
Kiitos. Kiitos, Dominik. Some very interesting topic. Kysymyksiä? Well, okay.
Either everyone fell asleep or...
I don't know what happened. But my question for you would be, you're recommending to go small at first.
Yeah.
But if I'm wandering around small and maybe larger, is it still, or my use case is something large? Should I still start small, or should I?
Yeah, if you already know that it will really be big, but most people say it will be big sometime, and then you have a Hadoop cluster and there's a terabyte of data in it and nothing is changing, and it's like, why do we have this Hadoop cluster? Then I would probably go smart about the technology choice and use something that can grow if it's just medium-sized, or go the full thing. Just go the full thing in that situation, if you're really sure that you need it, and you will have it. But just think about it. I think that's my core message here. Yeah.
Okay, we have a question here.
Well, my question is about skills and practices in organizations. So basically what you're saying is that technologies and approaches to data management, they are evolving and changing and moving forward. How do you see how organizations, like traditional roles like DBAs, people who are like owning the data, managing it, do they their skills evolve and get better aligned, and how to, if not, then what to do?
I honestly think microservices, as long as you don't allow for a plethora of different technologies. If you now open the floodgates and your developers can choose whatever they want, and suddenly you have 10 different databases in your productive system and you have to maintain them, then you have a real issue. On the other hand, in microservices, by separating the data out and drawing clear lines, which is typically possible, you don't have to normalize everything to a degree that everything is in the end connected to the customer. You make the individual data models simpler, and the individual data models, due to the simpleness, no longer require those massive skills. I have seen too many situations where there is this DBA, and there is this huge Oracle DB2 or something where they have this very, very, very complex connection, and you're really not allowed to do anything without the okay from the DBA, because it's so holy. If you split that apart and still stick to the same technologies, it already gets easier. It already gets way easier, and you don't have to enforce such strict controls because you're always afraid that someone will run the 7-degree join and kill your database. Because there's just not so many tables that you can join within your small microservices. So you have to manage complexity, and I think this helps. And especially in the relational space, I have the personal perception, and I see success at clients doing that. A lot of the stuff where you used to need a big system can nowadays done with stuff like MariaDB and PostgreSQL. And some of those developments, especially, for example, in MariaDB, they have this Galera cluster. It makes it much, much easier to operate. So yes, it's not as high scale as the Oracle. Yes, you partition it so you make it easier to manage, because you just have one functional space in there being serviced by one service. That makes it easier. But if you allow, of course, for 10 different databases, then you have a skill problem. But I think it's already a valid option to upgrade, go a little bit for the open source route, use the new capabilities, and off you go. This is not the perfect sales pitch. I should tell you, drop everything, buy Accenture, and do everything new. No? Okay. Good. Thank you.
Okay. There's one more question.
Hi, would you be willing to elaborate a little bit more between choosing HBase and between Cassandra versus Cassandra? Do you have any kind of personal experiences on or guidelines?
I have personal experience with both. It depends on your use case and on your general ecosystem. A lot of customers feel more confident, especially if they're setting up Hadoop anyways, because they want it for analytics, to use HBase because it has consistency guarantees that you're getting Cassandra only if you turn these transactions on, and I'm not 100% sure whether that really works safely. So in HBase you have a consistency model that is only row-based, but it is very per row it's effectively ACID, and you don't have eventual consistency. Cassandra really is the best choice if you have very, very high write pressure, really high write pressure, and if you're going for global distribution or stuff like so. Because if you're going for global distribution, you're going to be eventually consistent anyways. Yeah, if you have a global system and you're posting a picture and your friend in Tokyo can like that, and that like is stored in the Asian system or inserted there, but the picture is here, you have eventual consistency, because at the end you have to sort somehow out how to get one view of the timeline at both sides. Yeah, so then you have to deal with that anyways, and then you can take the plunge, I would argue. Both systems, from the way they are structured, because they have this tabular structure, feel relatively normal to people that have learned relational databases. However, you shouldn't be tempted too much. For example, in Cassandra, the indices are a tricky thing, because really HBase and Cassandra are a map of maps, and the indexes are bolted on. In HBase, by the way, you could use Phoenix and then use SQL. Does that go in that direction? But they are both mature choices, both rock solid, both in production, and Cassandra is arguably simpler from an operational perspective.